This is the 60mm mortar cannon capable of operation in both handheld and conventional mode with the assistance of its bipod legs. When ready, the soldier drops the round, which activates the detonators through the firing pin, initiating the propellant charge. In simple words, the distance the round travels is directly proportional to the number of charges applied. Interestingly, this is how it is aimed in handheld mode. A mortar is strategically aligned alongside the muzzle for azimuth, while the elevation can be monitored by observing the range and scale on the handle. In simpler terms, adjusting the barrel at a higher angle will result in the round covering a shorter distance, while decreasing the angle will thrust the round much farther. The precision in aiming the crosshair involves a two-handed approach, where the operator deftly manipulates the tripod elevation using the knob as visually depicted in the forthcoming animations. So stay tuned and don't miss a beat. The M224 60mm mortar is a muzzle-loaded, smooth-bore, high-angle-of-fire weapon. It consists of four basic parts. Number 1. The M7 base plate, located at the bottom, is a one-piece circular aluminum forging base. Number 2. A 60mm cannon is a muzzle-loaded, smooth-bore, high-angle-of-fire weapon. Number 3. Just beside it is the sight unit, a device on which the gunner sets deflection and elevation to hit targets. Number 4. And finally, we have the collapsible bipod assembly in conventional mode. This mortar was intentionally designed to be small and mobile. Comparing its size to a person will help you understand its dimensions. It weighs around 46 pounds in conventional mode, which translates to 21.1 kilograms. When converted to handheld mode, it weighs only 18 pounds, which is approximately 8.2 kilograms. Operating this simple weapon requires a mortar squad consisting of 3 soldiers. Their positions and principal duties are as follows. The squad leader occupies a position that best controls the mortar squad, situated to the right of the mortar and facing the barrel. Additionally, they serve as the FDC, Fire Direction Center. The gunner stands on the left side of the mortar, enabling manipulation of the sight, elevating gear handle, and traversing assembly wheel. They input firing data on the sight and adjust the mortar for deflection and elevation. When necessary, assisted by the squad leader or ammunition bearer, the gunner shifts the bipod assembly for significant deflection changes. The ammunition bearer positions themselves to the right rear of the mortar. They prepare the ammunition and assist the gunner in shifting and loading the mortar. Let's review the procedure for firing the handheld mortar cannon. Step 1. In this scenario, 2 crew members are required. One to load the handheld cannon and another to fire it. Step 2. The gunner kneels on the left side of the mortar, holding the cannon with the left hand, while the right hand operates the trigger and handle, as shown here. Step 3. Check and adjust the selector to either drop or trigger fire, depending on the chosen plan. Step 4. Position the mortar by aligning the sight over or alongside the muzzle for azimuth and observe the range scale and the handle for elevation. Use the red scale for charge 0 and the black scale for charge 1. In simple terms, raising the barrel at 80-degree angle, the round will travel less further in the battlefield as shown in the visuals. By lowering the barrel at 50 to 60 degrees, this helps the round to travel further distances, but all this depends on the mortar round as well. Step 5. Once the target alignment is correct, instruct the assistant gunner to load a round with the appropriate charge. Step 6. Double-check the target alignment and gently squeeze the trigger. Step 7. Upon impact, the round activates the detonators through the firing pin, triggering the propellant charge. The greater the number of charges, the farther the round will travel. This explosion of the charges helps propel the mortar to the desired target. This is the 60mm mortar, segmented into several parts. At the front, there is the impact fuse along with various burst modes, proximity, near-surface burst, impact, and delayed mode. Just below the fuse lies the high-explosive filler. Sandwiched between it is the ignition tube, which aids in initiating the explosion. The rings surrounding them represent the propellant charges, determining the distance it will travel. The greater the charge, the more it will travel to its designated target. At the base stands the detonator, and adjacent to it are the fins that help maintain the mortar's flight path. We all know that the most crucial process in conventional mode is aiming and targeting through this sight. So let's see how this works. The gunner rarely ever sees the target. A specialized soldier called the FO or Forward Observer spots the target, relaying this information to the FDC or Fire Direction Center. Step 1. First, the ground beneath is well dug to ensure that all the bubbles in the sight are level. For proper targeting, aiming points are set 50 meters apart. The gunner aligns the vertical crosshair of the sight with the left edge of the aiming point or stake, as shown through the sights. When fired, the sight is immediately rechecked and realigned in case the gun moved. Step 2. This is how he uses the sights. The elevation knob tracks and moves the crosshair up or down, while the deflection knob moves it left or right. To aim the crosshair, he uses both hands and adjusts the tripod elevation using the knob as shown in the animations. Step 3. The FO or forward observer calculates data using the M8 plotting board and sends the data to the squad leader or fire direction control officer. Step 4. The gunners use the sight dials of almost exact deflection and elevation from the fire direction control as shown here. Step 5. The loader then sets the impact fuse to proximity, near surface, impact, and delay mode. The proximity fuse causes the round to burst at 3 to 13 feet, which translates to 1 to 4 meters above the target. The near surface burst explodes just 1 to 3 feet above the ground. The IMP impact fuse bursts when the shell reaches the ground. The delayed mode works for small structures and explodes half a second after impact. Step 6. Mortar rounds, when dropped by the loader, hit this sharp firing pin located at the base of the cannon, which triggers the detonators and activates the ring charges. This results in the very high explosive gases which propels the mortar to the desired target. Let's examine the brief pros and cons of this mortar. The 60mm mortar is relatively lightweight and portable compared to larger calibers, such as the 120mm cannon, which is significantly bigger and heavier, making it more challenging to transport and deploy across different terrains. It can be set up relatively quickly, enabling a rapid response to changing battlefield situations. Whether in handheld or conventional mode, a single soldier can operate it, allowing for a quick reaction force. A smaller size offers more flexibility in positioning and maneuvering through challenging terrains. However, the 120mm mortar requires a transport system like a tracked vehicle, such as the Iron Sting, to transport or fire the mortar due to its heavy weight. Now let's discuss the cons. Limited range and payload. In comparison to larger mortars, the 60mm cannon has a maximum range of 3,400 meters when mounted on a bipod and a minimum range of 70 meters. Meanwhile, the 120mm mortar boasts a greater range of approximately 7,200 to 9,500 meters. While effective against infantry and fortified positions, the 60mm mortar may not be as effective against heavily armored targets. We make original 4K 3D animation with a small team of animators, so please support us by subscribing and dropping in a comment for more exclusive engineering animations made just for you guys.